Okay, hopefully this is our last example, because I've been on both knees and I think my legs are about to break off. Alright, that's the problem when you hang this thing this low. So, I figured that I would make one a little bit easier than the rest that we've been looking at. So let's graph secant, but we're not going to graph secant. What are we going to graph? Cosine. So instead of looking at this function, we're going to look at this function. Right? Simple. I'm not going to go through all the steps. If you trust me, that'd just be great. The left endpoint, when I set this equal to 0, is going to be pi. The right endpoint, when I set this equal to 2 pi, is going to be 3 pi. Right? Makes sense, doesn't it? Instead of starting at 0 and going to 2 pi, we shifted pi units to the right. So we're at pi and 3 pi. Did we change the length of the period? No. So the period is still 2 pi, which means delta x is 2 pi over 4, which is pi over 2. So we know where to start, we know where to stop, we know how to scale our graph. Here we go. So, a review of graphing cosine. Let's make our scale pi over 2. Come over here this time. So my first point is at, my first point is at pi. My second point, pi over 2 units away, pi over 2 units away, pi over 2 units away, pi over 2 units away. This is a cosine graph. The first point in cosine is supposed to have a y-coordinate of 1. But what are we doing? Moving it down 1 unit. So this is the actual placement of the first point. The second point in a cosine wave is supposed to have a y-coordinate of 0. But we're moving this down 1. So that point moves down to here. The second point in a cosine, or excuse me, the third point in a cosine wave is supposed to have a y-coordinate of -1, but we move it down, right? This fourth point is in the same spot as the second, and the fifth point is in the same spot as the first. So here is cosine. Max, intercept, min, intercept, max, intercept, min, intercept, max. So here's the cosine wave. Again, freehand, so forgive me. So if this is our cosine wave, we're not graphing cosine, remember? We're graphing secant. What is secant? It's the reciprocal of cosine. We run into the same problem we did with the cosecant graph. Not where these intercepts are, where they were from the start. So in other words, these are the intercepts of this cosine wave, but it's not about what they are, it's what they were supposed to be. In other words, the second and fourth point of a cosine wave are the intercepts. Second and fourth point in this period. So those points that were supposed to be intercepts now become asymptotes. So again, we're not looking at the points that actually end up being intercepts. We're looking at, sorry, what am I doing here? Yeah. We're looking at the points that were. All right? And then what do? We take this piece between the asymptotes and we flip it over. We take this piece that was between the asymptotes and we flip it over. Notice it's different here. This kind of like was shunted, it stopped, but this is going to go on forever and ever because it's got asymptotic behavior. So we get that flipping action for all of those bumps in that. And we don't need this anymore. The cosine graph was there to provide some anchors, if you will, for all of the flipping and the points that we were going to use. So, secant and cosecant are flips of these bumps after we put the asymptotes where the intercepts were supposed to be. Good luck.